Hey, what's up, everybody? I've made a new update to MegaScript, and this one is absolutely huge. I've added so much stuff. So first of all, let's just jump right into it. Let's kind of read down this little list here. So first of all, we can create object variables now. So you can make a variable to point towards an object, so you don't have to make the you don't have to do the full path every single time. So let's say object A equals world.cube. Then we can do a dot position dot x equals 8, and that'll move the cube. So it's this exact same thing as doing the regular one, although it's just quicker and it uses less CPU cycles. So also, this is going to be out of order, but I also added an ability to destroy an object, and attempted to execute an invalid bytecode. Alright, I fixed it. I don't know why that was messed up, but, well, I do know why, but it was just some little small thing. But anyway, you can destroy objects now, so you can do object a equals root dot world dot cube, and then you can do a dot destroy, and there we go. And also, another cool thing about this is whenever you destroy an object, the MegaScript will automatically go through all of the symbols and the stack values, and it will check all the object pointers, and if that object pointer is equal to the object that you just destroyed, it'll get set to 0. That way, you don't have a segmentation fault or a memory error whenever you try to use that object again. So, like, if I do echo a.count, it'll say the object does not exist because that object pointer was set to 0. So, let's see, what else do we have? So, we've also got, let's see, fixed file loading. Oh yeah, this is a really cool thing. So, now you can actually load files on Windows now. So let's load, for example, let's load this color.mlib, loadlib color.mlib, and then we require color, and then we can do stuff like echo RGB one. Let's just do 00255 for blue, and that'll give 255. So if we look in here, this is the code for that. And oh yeah, also one thing I don't think I mentioned before is that whenever a library script is done executing, it will set its setting. It'll add a setting called read only. So if let's say that we wanted to echo this variable AB, that'll be 4. But if we try to change the AB, if we try to do AB equals 2, memory is read only. So you can't change the values of a library script that's in memory. So it's like it's a good security feature. So what else have we got? We've also got oh yeah, I also removed the length variable from the script struct, because it was kind of pointless, because you can just get the length of the string with the string length. But we also fixed some errors and some bugs. You can also set an object's parent. So let's say we want to set the object a equals root.world.cube. So let's say that we want to set the parent to be root. If we do that, it disappears because now the parent is root. So, but if we do set root.world, it's back because we set it back to the root.world. So, what else do we got? Set parent, added new. Oh yeah, this is really useful. So this is a new initializer function. So instead of having to do all those function calls to make all the symbols and classes, you can actually just make a big initializer list, and you can do it this way, and it's really useful now. So you can just make this big initializer list, and then you can just call one single function with the initializer list, and then all of that will be done immediately, which is really cool. So what else do we got? Added the ability for scripts to create objects. Oh yeah, so we also can actually make objects now. So it depends on the privilege level of the object. So some certain scripts won't be able to create some objects that are like locked, because it's a good feature to prevent people from doing what they're not supposed to do. So let's create an object b equals create sphere, and then b dot set parent root.world. And as you can see, we've got an object, or we've got a little ball right there. I don't know why he's I still need to fix the freaking physics on my engine. My engine is so freaking engine physics are so not correct. They're just whatever. Anyway, so let's see. Let's make sure I'm still recording. Okay. Set new object. Yeah. Oh yeah. Also, you don't have to type new before every like struct or every enumeration anymore. You can just do struct test int a int b, and then you can just do test a echo a.a, and then there you go. So yeah, that's a lot better now. So let's see, when an object is deleted, oh yeah, I already covered that. Bool container, oh yeah, bool containers now will actually make a type def, so you can use the same settings for multiple variables. So let's say we want a bool 8 test 1, let's do 1 2 stop, and then we're gonna do test A, test B, and then we can do B.1. What the fuck? Alright, there we go. So I fixed it. It was because I forgot to expand the bool containers. So as you can see, you can do you can change their values. So 2 equals 1 echo b.2, and that'll be 1. And another really cool thing is that you can add these to structs too. You can also add them to structs, and for an example, I'll do root.world.sphere.settings.physics.off equals 0, and as you can see, that changes its setting because it's part of the sphere struct, which is really cool. So what else do we have? What else we've also got pass-through functions. Oh yeah, this is a really cool feature. So right here you can actually pass you can make a function that passes from MegaScript over to C. So you can add a function callback to MegaScript. So for example, this one here, test called back ASM, and it's called test. And if we go up here and look at it, all it does is it prints the type number of the value that you pass into it. So let's see, let's go do test 1, and that's 5. And if we go look over in the settings, if we go look in the settings and go over to 5, if you look, that's int 64. And we passed in the 1. We passed in the 1 variable, which is the int 64. And then we can also do like int a equals 0. And then if we pass in a, it'll do 22, because 22 is the symbol type, and a is a symbol, or in other words, a variable. So normally, if you were to do a function like a echo 1, if you were to do this function here, if you were to do echo type of a, it'll say pointer. It's a raw pointer. But if we do type of test, that's an ASM function, and these are special pointers that actually point to real code. They're real pointers, and they'll always be real pointers whether the environment is virtualized or not. And speaking of which, let's get into non-virtualized environments. So now you can actually make an environment that uses real pointers. So if we go over here to dim viewer, well, first of all, let me show you. So if you were to do like int a equals allocate 4, and then we're gonna echo a. As you can see, it's a really small pointer because these aren't actual real memory addresses. These are virtualized memory addresses. So if we do free a and then echo a, as you can see, it uses a memory manager that I made from scratch with an algorithm that I made too. It's really cool, but if you don't want that, if you want real pointers all the time, then you can easily do that by just going over here, and whenever you create your script environment, just do create non-virtualized script environment. And now whenever we go over here and do this again, we're going to do the exact same thing, and hopefully you'll see that these are now real pointers. What the fuck? Why does this shit keep breaking? I don't get it. Why the fuck? It worked before. Is it this? Oh, okay, so it was that. Alright, I'll have to fix that later, but basically, alright, so now whenever we do a pointer, allocate for whenever we do a pointer now, if you echo that, as you can see, it's a much bigger number because it's a real pointer, and you can do as you can see, it doesn't zero it correctly because I don't have any zeroing function for real pointers, but you can still change the value and stuff, and as you can see, it works. Yeah, it's the real pointers are really good, are gonna be really good if you want to like if you don't care about privilege levels and if you don't care about security, if you just want to do stuff in MegaScript with like absolute absolute potential, you can just set it to be real pointers, and then you can do everything in the master script, and that will make that like, and whenever you have real pointers, I'm pretty sure that I could maybe at some point find a way to actually call like functions and DLLs directly from MegaScript, which would be really freaking cool. Now let me go. I'm gonna figure out what caused this. It's gotta be something to do with it's probably because I don't know, I'll have to figure that out, but let's just change that back to normal. Pass through functions break when not unvirtualized. So there we go. So let's see what else. Fix some memory errors. Oh yeah, and this is a really big thing right here. So before, I just pushed raw pointers onto the stack for strings, and this was really limited because it saved space, but it also, you couldn't really change the string without messing up the code. So what I've done is now I've changed the strings to behave very similar to C strings. So now if we do echo hello, it does hello. But let me show you. So before it would have been pointer, but if we do type of now, it'll be C pointer. And if we want to actually assign this string to a variable, we can do char a, and it's a pointer character. So basically, it's just like C. It's just strings are just are just arrays of pointers, or just arrays of characters. My bad. So if we do hello, I am a string, and there we go. If we do that and then we echo a, it echoes the whole string. And we can also do really cool stuff like if we want to make a string from scratch, we can do that. So allocate for, and then we can do b equals a, and then b plus 1 equals b, and then b plus 2 equals c. And the last character will be automatically 0 if you have virtualized memory, so we don't gotta worry about that. So now we just echo b, and as you can see, ABC. Look at that, isn't that cool? So there's just one more thing I gotta show. So now you can actually change you can actually get the name and change the name of objects now. So if we did, let's say echo root.world.cube.name, it echoes the name of the cube. But if we wanted to do world.cube.setName, if we wanted to set the name to be prism, we can do that, and now it changes the name of the object. So we're gonna do world.prism.name, and as you can see, it echoes the name of it echoes the new name, and you actually access the object via its new name. And you can do that to set the name of a brand new object that you've just created, which is really useful. But yeah, that's just a quick overview of this update. If you guys have any questions, or if you want to add any suggestions to the comments, you can do that. Just leave a comment, I'll probably look at it. And if you liked the video, leave a like. I would appreciate it. I hope you guys think that this is cool, and I'll see you next time. Goodbye.